again. On this chapter you're going to learn about integration. You've already covered integration in core 1, but there are some other bits to integration that you can learn with regards to core 2. Okay, most of you know what integration does. Okay, it's the opposite action that you would do to differentiate. Okay, if you differentiate, integration is the opposite of differentiating something. Okay, for example, like if I gave you a function called y is equal to x cubed plus 3x squared plus 2x. If I differentiate this dy by dx, I get 3x squared and 6x plus 2. Okay, so this is the function of the differential. Alright, but if I want to get my original function back, I would have to integrate this. Okay, so if I want to get my original function back, now look what I'm trying to do here. Dy and the dx goes there to the other side because the whole equation is multiplied by dx. Now if you're faced with a situation like this, you put this integral sign. Okay, so this sign is basically the integral sign. Okay, and then you integrate it. Okay, so this side is basically y. Oops, let me change my font color. That's basically y. And if I integrate it, okay, so what do you do when you integrate? You add a power to the x, okay, to the power that is already there is, okay, so that's 2, x to the power 2, so you add a power to it, so that's x to the power of 3, and then you divide the new power. Alright, you divide the new power, okay, you divide the coefficient that you have already by the new power, okay, and then you do the same for this. The power that there is on the x is 1, so you add a power, that's x squared, and then the new power, you make that, you divide the coefficient by the new power, okay, and 2 has no x terms, x to the power 0, so I add 1, so x to the power 1, I don't need to show that, divided by 1, so I get my original function back, because this 3 and this 3 cancel. 6 divided by 2 is 3, and 2 divided by 1 is still 2, so x cubed plus 3x squared plus 2x. Now that's what I had originally, and I get that back. Okay, but when you integrate, you also put this thing called c, saying you get a constant term. Okay, now we'll look on that later. Okay, but you've got to put this c whenever you integrate. Okay, you've got to put this c showing that there could be a constant term. Okay, but this one doesn't have a constant term, so if you had any other information pertaining to this graph, this constant term would be 0. Okay, but whenever you integrate, you've got to show that c. Alright, so basically integration is a reverse process of differentiation. Okay, alright. Now you're going to learn something new called definite integration. Okay, definite integration. With definite integration, the practical uses of this is that you could work out the area between two given points of a graph. Okay, so if I had a graph like this, I could work out the area between this point where x is equal to 0 and x is equal, let's just say it's 5, between area between the x-axis and the graph. Okay, so that's what definite integration does for you. Alright, and we'll see how that works. Okay, so I'll give you a function like this. Okay, so that's y is equal to x plus 2. Okay, and let's say you were asked to integrate, do the definite integration between x is equal to 2 and x is equal to 5. Alright, now the symbols you use to show that you want to integrate this and you want to do the definite integration between points x is equal to 2 and x is equal to 5, this is how you use the symbols. Okay, you say the integral of x plus 2 and you put a dx. Okay, and you've got to put the furthest point to the right on the x-axis, that on top. Okay, and the other point at the bottom. Okay, so the furthest x point on top and the other point at the bottom. All right, and then you would integrate as normal this function x plus 2. If you integrate x plus 2, you get x squared plus x squared divided by 2 plus 2x. all right, okay, and you would also get your constant term. Okay, for now I'll just put the constant term, and these values here you create square brackets. Okay, you got to put these square brackets and put again the 5 on top and the 2 below. all right, okay, and next what you do is you got to substitute 5 instead of x. Okay, so this constant term does not have an x term. Okay, so usually when you do definite integration, you could actually leave out this c. Okay, so you don't have to put that c because that does not involve an x value. Okay, so when you do definite integration, you can leave out the c. Okay, so if I substitute 5 instead of x, I get 25 by 2 plus 10. 2 times 5 is 10. all right, next what I do is this. I substitute 2 into this, but the result that I get from that substitution, I've got to subtract that from this. So I substitute 2 into that, so that's 2 squared, which is 2 squared is 4. 4 divided by 2, and then 2 times 2 is 4. I was going to say 2. 2 times 2 is 4. all right, and that's what you get. all right, so you substitute 5 into it, you get that result, and then you subtract you substitute 2, and then you subtract that result from the substitution of 5. all right, so this would give you 12.5 plus 10, 22.5 minus 6, which is 16.5. all right, now so that's the area enclosed between the x-axis and the points x is equal to 2 and x is equal to 5. all right, so if I were to show that graphically, okay, so I've drawn out the function for you. all right, so this is the y is equal to x plus 2 graph, and this is where you'd get your x coordinate 2, so the y coordinate will be 4, x coordinate 5, y coordinate will be 7. all right, so let's just work out the area enclosed between the x-axis and these 2 points in the graph by using the trapezium rule. We can see there's a trapezium here. all right, so this height from 2 to 4, so that height there, sorry, not 2 to 4, from 0 to 4 going up on the y-axis, that's 4, and that's 7, and this length here is 3. So for the trapezium rule, you do 7 plus 4 divided by 2 times 3. That's how you work out the area of the trapezium. So 7 plus 4 is 11. 11 divided by 2 is 5.5. 5.5 times 3 is indeed 16.5. See, so the results match up. So you've used definite integration to work out the area between the x-axis and between 2 points on the graph. Okay, area enclosed between the x-axis and the graph. Okay, right, now you think to yourself, now I could just do this using the trapezium equation. Why am I bothering myself with the integration? Well, it's easy enough for linear functions to use trapezium rules, or you'd get triangles at times to work out areas enclosed. But if you had a function like this, a parabolic function, then it'd be more challenging. Okay, a parabolic function like this. Okay, so there's a curvature here. all right, no, so there's no real formula for you to work that out straight away like what we did here. all right, so you'd have to rely on definite integration to work something like this out. A graph like this could have an equation y is equal to x squared plus 2. all right, and I want you to work out the area enclosed between the graph and the x-axis between x is equal to 0 and x is equal to let's say 3. Let me make that a let me make that a even number. X is equal to 4. All right. So the area that I'm looking for is this. So that's the area that I'm looking for. Okay, so that's an awkward shape there, so you don't have a formula to work that one out, so you'll have to rely on definite integration. Okay, so let's work that one out. So what are the symbols you use? You've got to first put the integration signs, the definite integration sign, so you put that sign there. So I put the biggest value on top, the smaller value on the bottom, and then I say I want to integrate my function. Okay, and then I integrate it. And remember, when you're doing definite integration, you can leave out, you could leave out the constant term. Okay, and then I put my square brackets, and then I put the boundaries between which I want to integrate. So then I've got to substitute these values in. Alright, now this time around I'm going to use a different method when I want to substitute these values in. Okay, it's really up to you how you'd want to do this. Okay, now in this example what I did was I substituted 5 into this for all the terms, and that whole result I subtract. I subtract this result. When I substitute 2 into this, and this result, this final result, I subtract that from the result that I got for 5. Okay, but here we can do it in a different way. I'm going to substitute 4 for the first term, so that's 4 to the power of 3 divided by 3 plus, and I'm also, sorry, not plus, beg your pardon, it's a minus sign, and I'm going to substitute 0 instead of x as well for the first term, for the x cubed term. Okay, so here I'm working out the difference for each individual term, and then there's a plus sign in between, and then now I'm going to subtract 4 instead of x for this 2x term, so that's 2 times 4, and then I'm going to substitute 0 instead of x for this 2x term. Okay, so I'm working out the difference for each individual x term. Alright, whereas here I substituted my first term into the whole equation, whole integral, the result of my integral, and then subtracted the differences for each of these values. Okay, whereas here what I'm doing is I'm substituting the one value for each of for one particular x term, and then I'm substituting the other value for that particular x term, and then I'm working out the difference, and then I'm adding the results for each one. Okay, after substituting both values in. So really, it's really up to you how you'd want to do it. I personally like this method, and I think most people follow this method. Okay, but you could do it the other way as well. Alright, so now what you get is 4 to the power 3 is 64 by 3, and that is a 0 because 0 cubed is 0, and that divided by 3 is still 0. 2 times 4 is 8, and then 2 times 0 is 0, so therefore 8 minus 0, so that's 64 by 3 plus 8. So the answer, I'll have to leave that in a fraction, okay, because I'm going to get an awkward value if I'm trying to get a decimal answer. That's 88 by 3. If I were to write that as a mixed fraction, it's 29 and 1/3. Okay, so that's the area enclosed between points x equal to 0, x equal to 4 on the x-axis and the graph. Okay, so you've seen how you use definite integration to work out the area enclosed between a graph and the x-axis. Okay, I hope you found that helpful. I'll see you in the next video where I'll do the second part on this chapter, where you would learn something called the trapezium rule. Okay, so I'll see you later. Bye bye.